Okay, we're going to talk about types of symmetry and test for symmetry. So there are two types of symmetry. There is line symmetry and there is point symmetry. So with line symmetry, what happens is I can actually fold something along a line and it matches up. So if you think about it like this. Okay, so I have 4 different emoji faces here. I have the winky face, the hearty face, the frowny face, and the silly face. So if I take the winky face, there's no line that I can draw in this and have it and fold it where it matches up. So this one actually has no symmetry whatsoever. So it's not symmetrical. Okay, but my heart face, if I fold it straight down the middle, then it matches up on both sides. So this has line symmetry. My silly face is kind of like my winky face. This is also not symmetrical because there's no nothing I can fold it at to get there. Now my sad face, again, like my heart face, I can fold it straight down the middle, and this also has line symmetry. The most popular line symmetries that we're going to have is going to be the y-axis, which is our vertical axis, or the x-axis, which is our horizontal axis. And we're going to talk a little bit more about those in a minute. So point symmetry is something that if I rotate an object, usually about a point, and our point's going to be usually the origin, 180 degrees, then our object remains unchanged. So if I rotate this S 180 degrees, it would lie on top of itself. It would be symmetrical at that point. Letters Z would be also symmetrical at about 180 degrees, but usually point symmetry is going to be about the origin. Okay, so now we're going to talk about the test to get us into these different symmetries. We're going to talk about the test for line symmetry, and we're going to talk about the test for point symmetry. There's the algebraic test, and then there's going to be the graphical test, and they're both pretty much the same. All right, so to determine if something is symmetrical with respect to the x-axis, we're going to take our xy points, we're going to keep x the same, and we're going to negate y. What that means is we're going to change y. If y is positive, we're going to make it negative. If y is negative, we're going to make it positive. So, for instance, if we have 4 times x plus 3 squared plus y squared is equal to 16. We want to know if this is symmetric with respect to the x-axis. So I'm going to keep everything else the same, but I'm going to negate y. What that means is I'm going to take y from whatever sign it is, and I'm going to plug in a negative y. I'm going to leave everything else the same, so I'm going to put in a negative y, but the squared is still there, everything else is still there. And then I'm going to simplify that. And what I want to know is, do I end up with the exact same problem I started with? So what is a negative y squared? Well, a negative y times a negative y is a positive y squared. Is this what I started with? Are these two the same? And that's the question. Are these two the same? If the answer is yes, then it is symmetric with respect to the x-axis. So if something is symmetric with respect to the x-axis, we keep the x the same and we change the y. So we're changing the y. We kept x the same, we negated y. We kept x the same, we negated y. We simplified it. Negative y squared is just y squared. Is this what I started with? Yes. Then it is symmetric with respect to the x-axis. Okay, for the y-axis, we're going to keep the y the same, and we're going to negate x. So that means we're going to change the x value. If it's positive, we're going to make it negative. If it's negative, we're going to make it positive. So for instance, if I have the equation y is equal to x to the fourth minus 4x squared, we're going to keep the x the same, or keep the y the same and change the x. So in place of where I see x, I'm going to put a negative x. Everything else is going to remain the same. So it still has the 4 as an exponent, the 4 as the coefficient. That's just happenstance. Negative x, and I still have the squared. And then I'm going to simplify. So negative x to the fourth power, does that give me a positive or a negative? Well, anything to the even power is always going to be positive. So this is going to give me a positive x, but it's still to the fourth power. Minus 4, again, same thing. Anything to an even power is going to be positive, and it's still squared. Is this what I started with? Are they the same? Yes, they are the same. So this is symmetric with respect to the y-axis. If they weren't the same, then it would not be symmetric with respect to the y-axis. With the origin, I am going to determine if something is symmetric with respect to the origin, we're going to negate both the x and the y, meaning we're going to change them both. So if I have the equation xy is equal to 6, I'm going to plug in a negative x and a negative y because I want to change both of their signs. I want to negate them both. If they were positive, I'd make them both negative. If they're negative, I'd make them both positive. I want to change both their signs. And then I want to simplify. What is a negative times a negative? Well, a negative times a negative is a positive. X times y is xy is equal to 6. Are these two the same? Why, yes. Yes, they are. Then this is symmetric with respect to the origin. Okay, so let's do a couple more. Okay, it is possible for an equation to be symmetric with respect to more than one thing. It is possible for an equation to not be symmetric at all. So, and I'm looking at just the algebraic form. You can look at the graph too, and the graphs are on your papers, or you can just graph them in your graphing calculator. It's no big deal either way. So I'm going to focus on the x-axis. If something is symmetric with respect to the x-axis, we have to negate the y. So I'm going to keep everything else the same. I'm simply going to negate the y. So negative y, and then I'm going to keep everything else the same. Squared minus x squared is equal to 1. Well, negative y times negative y is a positive y squared minus x squared is equal to 1. Is that what I started with? Yes, then it is symmetric with respect to the x-axis. So now I want to check the y-axis. For the y-axis, I'm going to keep the y the same, and I'm going to negate x. And everything else stays the same. So y squared minus negative x squared becomes a positive x squared. is equal to 1. So make sure that these two negatives, this is from the problem. This has nothing to do with me squaring the x. Negative x times negative x is a positive x, but these two negatives come from the problem. And that's okay. That's what's supposed to happen. Is this what I started with? Yes, it is. So it is symmetric with respect to the y-axis. Now let's check the origin. In the origin, I'm going to, if something is symmetric with respect to the origin, I have to negate everything. So negative y squared becomes positive y squared minus negative x squared becomes positive x squared is equal to 1. Is this what I started with? Yes, it is. So it is also symmetric with respect to the origin. So this particular equation is actually symmetric with respect to all three of them. It's symmetric with respect to the x-axis, the y-axis, and the origin. Okay, so let's look at this one. This is y is equal to the cube root of x minus 1. If I keep x the same and I negate y is equal to the cube root of x minus 1. I want to get y by itself because that's kind of what the original problem was. So y is equal to negative cube roots of x minus 1. Is this what I started with? No. So it is not symmetric with respect to the x-axis. So now I want to negate, I want to keep the y the same, and I want to negate x. Y is equal to the cube root of negative x minus 1. I can't really do anything else with that. Is this what I started with? No. So it is not symmetric with respect to the y-axis. So my last one tells me that I need to negate the y and negate the x. Again, I really don't like my y being negative, so I need to solve it for y, so I got to get y by itself. So y is equal to the negative cube root of negative x minus 1. Is this what I started with? No. So this is not symmetric with respect to the x-axis. It is not symmetric with respect to the y-axis. It is not symmetric with respect to the origin. So this one actually has no symmetry whatsoever. So so when I asked for the symmetry on this, this would be none. Okay, so we're going to do all three tests on this one. We're going to try the x-axis first, so we're going to negate y. So I'm going to put negative y is equal to negative absolute value of x minus 2. Again, we don't like y to be negative, so I'm going to divide everything by negative 1. So y is equal to a positive absolute value of x plus 2. Is this what I started with? Nope. So it is not symmetric with respect to the x-axis. For my y-axis, I'm going to negate x. So y is equal to the negative absolute value of negative x minus 2. What is the absolute value of negative x? Well, that is a positive x. Is this what I started with? Yes. So that is symmetric with respect to y is equal to x. That doesn't mean I can stop, because it can be symmetric with respect to two things instead of just one. So y is equal to negative y, because I have to negate them both, is equal to the absolute value of negative x minus 2. So I'm going to divide everything by a negative 1. So I get y is equal to, two negatives make a positive. I'm going to take care of the absolute value of negative x and get positive x plus 2. Is this what I started with? No. So it is not symmetric with respect to the origin. So the only one it's symmetric with respect to is the y-axis. Okay, so three tests, one where I negate y, one where I negate x, and one where I negate them both.